Hello and welcome back to the shop. I've been exploring a few things recently and I wanted to capture this in a video for something specifically that I've been working on with regard to water-cooled belted sharpening. There's a lot of opinions out there, especially on the YouTube, about belted sharpening. And I before I go into the water-cooled part of it, I want to try to share where I stand on belted sharpening. This is how I like to explain it and try to capture it. So first off, let me just touch a knife to a belt. Okay, so I think that most reasonable people would be able to come to a conclusion that I did not just destroy that blade, right? Like in capital letters, the blade is trash now. Like I overheated it and I ruined the temper. But that is you will find that opinion out there. So now, what if I hold it to the belt just a little bit longer? Okay, so now that the question, right? Like the question is like, at what point do we actually get to the stage where we do damage the knife? So let me hold the tip of the knife right against the belt. Okay, and that comes off pretty hot. That almost burns my fingers. It didn't blue, it didn't change color, but it got really hot. So the point that I want to make by demonstrating this is that the mere act of using a belt isn't going to destroy a knife, but you can destroy a knife by using a belt. So what we're looking for is that spot in the middle where we can get the work done that we need to get done, but not damage the knife. And the damage comes in form of heat, and that's a really complex equation of like how hot and how long you get a steel to a specific temperature so that the molecular structure of it changes and it gets softer. That's what we're worried about. So the whole like water-cooled part of this was an exploration of like, I know there's a gray zone in there. Is it possible to get more work done faster, either by speed or pressure, by including some water to keep the blade cool as I go? Can I save any time by doing this? So that's the genesis, the origin story of why I explored water-cooled belted sharpening. And next, I want to show you what I used to try this out. So what I have here is an off-the-shelf mist cooling system, and the way this works is we run compressed air into one hose of it going into this block, and we have the other hose going to some water, and the air flows through that block and pulls water from the jug and then sprays it out this nozzle. You can control both the airflow and the water flow with those two settings. It has a little magnet on the back, but this is an aluminum housing, so the magnet doesn't work. And you see I rigged it up with a clamp and a block on my 1x30 belt sander to spray water right here above the belt. I do my grinding here so the knife blade gets wet and stays cool, which, looks pretty good, right? I'm going to shift to voiceover here as I fire up the machines. But first thing to notice is the rag there. So one small downside and partial upside of using the wet system is that the water does come off of the system and create a bit of a mess. The potential upside of that is that it gets the dust off from grinding wet as well, so that it doesn't become airborne. So that's kind of let's call that one a wash. And so now I'm taking a few passes here. I'm using the same sort of stroke that I would use if I were working dry. And that sort of gets to a point where, so it does, look at the water there, it certainly does stay cool. I wipe it off, I can see, actually you can see the burr there pretty good too. It wasn't quite up all around, so we're going to end up doing 2 passes per knife here. But that's, touch up the bolster there. On that blade, it didn't need a ton of work, so I'm not sure I saved a whole lot of time. But again, we're just kind of doing the sequence here. You can see that the blade does get wet. That keeps it cool. It's in a little blanket of water because the water is getting sprayed onto the belt before the belt gets to the knife. I'm going to double the speed of the video here to get through a knives, kind of just to show the fact that I'm doing a pretty decent batch of knives, but also I want to get to the part that lets me explain the biggest downside of this experiment so far, and that is that the belt seems to get gummed up, certainly faster than it does when I run the belts dry. And then I can clean it. I'll show you a cleaning stick here that I use, and I think you've probably seen these before. This little thing that looks like a giant eraser. You clean the belt and it starts looking better, but the belt seems to get gummed up quicker and quicker and quicker. And ultimately, what I think I've come to the conclusion of is that the belt life is diminished by using them wet. And I do realize that there are some belts that are designed for wet grinding. So there might be some opportunity to continue this experiment with a different style of belt. For clarity, I am using Cubitrons for this experiment. And I'm doing this work where on the coarse belts, this one's a 120, but it is, to me, the application that makes the most sense is when I'm doing the most work on the blade, which is the rough work, cutting bevels and doing repairs and such. So ultimately, what I think that boils down to for me is that the reduction in life wear, see now I kind of need to do it every knife. I need to come in and touch the belt to try to clean it up. So the reduction in belt life does not make up for any advantage that I'm getting by keeping the blade cool while I'm using water. If anything, now I have to push harder because the belts are wearing out. So like if it's a net zero or net negative to me. So after working through this for about a month, I think I'm back to the point where I am going to stick to dry belt grinding. I'm not ready to give up on the water-cooled system. I think there are other places where it could serve a function, but in this application, I think I'm going to hang it up. Okay, so in conclusion, so far where I stand on this is that the water cooling does improve the maintaining and controlling the temperature of the steel while grinding. That improved benefit, I don't think outweighs the cost of reduced belt quality, the way they gum up, and even when I try to clean them, I feel like I'm not actually getting ahead. So I'm not ready to discard my misting system. I'm going to keep it. I'm going to explore different places where I could use it in my shop. I might revisit it after time. There's more opportunity to experiment with other belts. But I'm at, for where I am, I'm probably going to hang it up and just go back to dry grinding on the 1x30 for the majority of the work that I do. If you have anything to add to this, if you've gone down this road before and come to a different conclusion, please leave that in the comments. I do monitor those over time. And thanks so much. If you made it this far, please hit the thumbs up and the subscribe button. It costs you nothing and it helps me out. So, and it's, yeah, I also have some other stuff I've been working on too, which I'm excited to share all in due time. Thanks a lot.